Is that all right?
I'm
Yes,
yes,
you're good. So, how's it not right?
It's a metal. Can you use your electronegativity scale when it is metallic? No. Okay. You do not use the scale when it is a metal. Okay. You got to recognize it's a metallic bond, and we don't use the scale for that. Scale is not designed for metallic bonds. All right. For SO2, you got what? 1. So it is. Okay. And N2. What do you think? Now, this one's tricky, okay? We don't, see how we wrote S and O, AS and I? We don't write N side by side with an N, right? But it's essentially an N bonded to an N. So when we do this, it's 3.0, subtract 3.0, which is what? 0. So what would an N2 be? It'd be nonpolar covalent.
So that's the only time you actually consider those numbers.
Yep. Now, to abbreviate, because I don't want to have to keep writing that out. If you want to abbreviate ionic I, or you want to abbreviate this one NPC, you can. Now, the last one, number 2, rank in order of increasing ionic character. I got to this in 3rd period yesterday, which is why this question is up here. If you look at your scale, I'm going to flip to a new page, just so I have a little more space to write. If you look at your scale from 4 to 0, all right, where is the most ionic bond up here between 4 and 0?
4.
Okay. This is most ionic. Where is most covalent? Okay. So if I want you to put these in order according to most, I know, I just saw it. If I want you to put these in order of increasing ionic character, which number would we have to go towards?
4.
That's right. All right. So if I go this way, I'm increasing ionic character. Okay. So I'm going to have from 0 towards 4.0 is going to be increasing ionic character. Now, do I always have to ask for increasing ionic character? What if I said increasing covalent character? Which way would I go? Towards what? Towards 0. All right. And if you don't think you remember this, put it in your notes. Okay. If I said increasing covalent character, we're going to go towards most covalent. So I would go from what number to what number? From 4 to 0. Now, who am I not going to use at all if I do this? Who? Okay, so do not use what kind of bonds? That's right. Because I did this very generically here, so you could include it in your notes. We'll go back and do the opening bonds in a second. All right, so if you want that for your notes, that is done very generically. You will see that information again very soon. Hint, hint.
You recorded this yesterday?
I did in your class, but that piece was in 3rd period, so no, that piece is not recorded, which is why I wrote it out. We got to a little more than y'all did in third period because they were faster on the puzzle than y'all were.
I think I might need one of those new sheets again.
What sheets? The
Ones you gave me yesterday.
you lose it?
Yeah, I think so. I had it this morning, but I don't know where it went.
All right, does everybody have it?
No.
We shall see. All right, how about now?
Yeah, sure.
Waiting on Sophie. Yes? All right. So if we go back to the opening, all right, I asked for increasing ionic character. So I started which one?
0.
Okay, we started at 0. So who is at 0? Okay. And then? And? And again, who did we leave out? We left out FE. Why did we leave out FE? It's metallic. Questions? All right, can we look at homework? See which one we had predicted wrong from the night before? Okay? Can I take it down? I hear your nose out there.
You go ahead.
I'm moving. Where is your mom? Over there.
Okay, that's good to know.
Why so random?
All right.
No,
Don't
it's
look
okay.
at
I got up this morning
She's
and I
on
heard
her- she's in her-
something failed. I'm like, what is that? And I checked it, it was my belly ring thing. I'm like, and I couldn't find it. And I don't have another one. I was about to cry. But I-
Tragic.
But I found it.
I'm glad to hear it.
It's that
Belly ring thing fell, but she found it. She didn't have no.
Your what?
my belly ring thing, the top
You
thing,
feel well?
it fell out the bed when I got up this morning, and I couldn't find it, and I was about to cry.
It's tragic. All right, so NaCl. What did you say?
Ionic.
Okay, ionic is a good answer. Now, given we're going to put these in order by one or the other character in a minute, we'll choose it a second. What number did you get when you predicted it? 2.0? What'd y'all say?
2.0.
2.09. Okay. And those 0? Okay. I don't speak Spanish, people.
Oh no,
Let me get on
four, it's got one
Huh?
more.
Let me get on.
I'm doing a homebound person, and you'll love this. I had to get a translator to be able to do homebound with Anka Ema. I have a go-between between me and Anka Ema. No, I don't need help from Anka Ema. All right, PCL5.
Non-polar point.
All right, 0.9. And so it's what?
Polar.
Polar
Great.
covalent. Now, you can abbreviate that PC if you want. Can you just write polar? No. All right. CAI2. 1.5. So it would be what? Polar covalent. Now, what y'all predict that was the night before? You said it was onyx the night before. So if you just look at the periodic table, that's a metal and a non-metal, you would predict that that is what kind of bond? You would predict that it's onyx looking at the periodic table because it's a metal and it's a non-metal. But when you subtract using electronegativities, it is actually what kind of bond? It's polar covalent. So if you are given the state test and they don't give you an electronegativity chart, you're going to use the table and onyx would be the right answer. But if they give you a section of electronegativities, is onyx going to be the right answer? No, they're going to expect you to know to subtract the electronegativities and get polar covalent. All right, what about HF? What'd you get there? 1 point what? So that would be what? And yesterday, we said that was what kind of bond? You said it was covalent because it was two nonmetals. That's another one that we would not predict right using the periodic table. CH4, you got what? Point what? 0.4, so that's polar covalent. And Cl2, we just did in the opening, we would learn that that was what? It's 0, so it would be nonpolar covalent. Now, the last one you had in the opening yesterday, or in your homework, was Mn. Mn would be what? Metallic. That doesn't change. So let's say since last night's, or this morning's opening said increasing, what do we do, onyx? Let's say we do, yeah. Let's say that we arrange these in increasing covalent character. Okay? All right, so who do we start with?
HS.
Whoops. All right, so NaCl, because that's 2.1, HF, CAI2, PCl5, CH4, and chlorine. Any questions about how to do those? We feel pretty good about bond types and putting them in order.
Yes.
So we could do 75% of the quiz tomorrow.
Yes.
Okay. Yeah, we haven't done everything. Don't need that. All right. Now, we need to talk about some vocabulary. Let me say this. Everything else that we're going to do today is covalent bonding. Okay? Everything else we're going to do today and really tomorrow until I tell you otherwise is going to be covalent bonding. Here, Jonathan. Now, before we could go, yes, my dear.
Well, we'll be having a surprise.
Now, we've been using the word molecule for, I don't know, several weeks now. I don't know how many weeks, but a while. All right? What is the definition of a molecule? We've gotten a little more sophisticated over the course of the last 10 weeks. So, that's an ion. Now, two or more atoms covalently bond. Now, when I say covalent bonding, what word do you think I want you to keep in your head for the next 2.5 days?
Bond.
Okay, I need another word.
Atom.
No.
Covalent.
Okay, I want you to look back.
Is it two? Is it molecule?
I want y'all to stop talking. Stop yelling out dumb stuff. It's not dumb stuff. It's just stuff that's not what we need for right now. You look back in your notes. And I'm going to pray that I actually told you this correctly, because I have seen your moments these days. Look back in your notes to the definition of covalent. Okay, that we did a day or so ago. And look at the definition of covalent. And let's pray that Ms. Wall gave you the right definition and we wrote down this word that I need. There you go. I did. I did not have seen your moments. What is that key word that y'all just yelled out? Share. Okay. So every time we talk about covalent, I need you to remember that we're talking about shared electrons, first of all. Okay? Shared electrons. So this whole topic we're talking about is that, oh, yes, my dear.
When you get to a moment, can I see you for just 1 second?
Well, I probably won't have one, so let me just stop and they'll all their choices and their chairs because I stopped talking.
Yes.
Didn't have to say yes to that.
She having a lot of moves.
Jane.
I know, but you know, I'm saying no.
I was going to go, you wait till next week.
Until Monday.
I would have told her, I don't either, but we really ain't got the
Y'all get number
show.
5 now.
I'm ready to go eat them.
You get number 5 now for real.
Don't start slowing something down now.
She does it earlier.
All right. So, where was I? Oh, 2 more atoms. Covalently bonded. So, when we talk about atoms that are covalently bonded, I want you to think they're what? Shared. So, how are you going to recognize that they're covalently bonded when you look at them? Okay, but when you just look at something, are you going to know it's shared? So what's that other stuff y'all were yelling out a second ago? Yeah, somebody else yelled out some other stuff that was important. There we go. All right. So in your head, you need to remember that they were non-metals. Okay? Because if I have an example of a molecule and I say SO2, if I have something like CO2, or if I have MnCl2, how can you say to me, oh yeah, Miss Wall, that's a molecule, that's not a molecule. Those all sort of look the same, don't they? One of those is not a molecule. How are you going to know which one is not a molecule? Has a metal in it. So who has a metal in it? That's right. You're supposed to be able to look up here at this point and go, that is not a molecule because that right there has a metal in it. Everybody okay with that? Yes? Okay. I'm going to assume you say yes to that. You mean it. All right. Now, a molecule has 2 or more atoms that are covalently bonded. That means the electrons are shared. Well, that's a really nice definition. I know what it means to say electrons are shared. I want you to know what it means to say electrons are shared, right? However, most people, when I say the electrons are shared, can't just look at it and go, oh, they're shared. That's great, Miss Wall. So how are you going to know they're shared when you look at the formula? You know they're shared because they're all made of what kind of elements? Non-metals. So when you look at the formula, is that made of non-metals? Well, you look up there, and they're on what side of the periodic table? They're on the right. You look up there, and they're on what side of the periodic table? The right. But where's Mn at on the periodic table? It's in the middle. It's in that blue. As soon as it's in that blue, it's what kind of element? It's a metal, and that tells you it's not a molecule. Okay? So, What's a diatomic
Two.
molecule?
Two.
Two what? Two who? Not two molecules. Two atoms. Covalently bonded. Okay? Two atoms that are covalently bonded. Now, we want to figure out which of those are diatomic molecules and why. I will tell you, not all of them are. All right, is CO2 a diatomic molecule? The first thing you need to decide is it a molecule at all? Is it covalent? Okay, it's covalent. How do you know it's covalent? It's two nonmetals. Okay, we're good on that one. Is it two atoms? The answer is no. How many C's does it have? One. How many O's does it have? So that's 1 plus 2, which is how many? That's why it's not two atoms. Okay? So you want to do the same thing for each one. So how many H and Cl's do we have? Well, first of all, is it covalent? Yes, it is covalent. Does it have two atoms?
Yeah.
One, and one is how many? So is it diatomic? Yes. This one is diatomic. Is Cl2 covalent? They're both chlorines are nonmetals. One chlorine, one chlorine. They're nonmetals. All right. Does it have just two?
Yes.
It's diatomic. All right. NaCl. Is it covalent?
No.
It is not covalent. It is not diatomic. It does not matter that it only has two atoms because it's not what? It's not covalent. Okay? Does that make sense? Yes? No?
Yes.
You think you can figure out if they're molecules or if they're diatomics? Yeah? Okay?
Yeah.
So, I want you to figure out if they're molecules, and if they're molecules, figure out if they're diatomic molecules. Okay? I'm only gonna give you like 8. Chill.
8.
Mm-hmm.
That's a lot.
Mm-hmm. All right. please.
Yes.
No.
The molecule can't be able to.
No, not do that.
I'll forget.
Anybody want to go to ISS4?
I would,
I do.
I'll do.
Be quick about it. All right. So if we look at question 1, SO3, is it a molecule?
Yes.
Okay. So SO3 goes here. All right, MgI2.
No.
Okay. Ki,
No.
CO.
Yes.
All right, I2.
Yes.
All right, HBr.
Yes.
SO2.
Yes.
HCl.
Yep.
All right, so 6 of them were molecules. Everybody agree with that?
Yes.
All right, so out of those 6, which of those 6 are diatomic?
CO. I2. HBr.
Everybody okay with that?
Yeah.
Yes?
Yeah.
Okay. Now, we have 2 vocabulary words to do with 3 sub-vocabulary words to do. And then we're going to learn to draw Lewis structures. Everybody okay with those? All right. So, the vocabulary words the state's going to expect you to know, which is a little odd to me, but I'm not in charge. Which one do we want to do first? Let's do bond length. The other one's bond energy. It doesn't really matter which one we do first. All right, bond length. Now, first of all, it's not the length of a bond. You know, you're not getting any points for that. All right, it's the average distance between 2 bonded atoms. Now, the reason we say the average distance is because atoms are constantly moving. So we can't measure an absolute distance. So we measure distances, and then we take the average. Okay? So what kind of motion, first of all, do atoms have? All right? And we'll talk about these again later in the semester. But there are three types of motion. First of all, atoms translate. Okay? Or you can call it translational motion. When you get up to leave my class and go to third period, or Sophie went to ISS for me and came back, she translated. Okay? That's the only kind of motion I have. Some of you might have the ability to rotate, or you have rotational motion. Even when I started teaching here and I weighed 120 pounds, I had no ability to rotate. People tried to teach me to flip. I was always afraid I was going to land on my head. But if any of you have the ability to do flips and can flip end over end, you can rotate. I never managed that skill. I was always afraid. And number 3, vibrate. All right, or vibrational motion. All solids have vibrational motion. Okay? They vibrate. Okay? So even if you're a solid and you're an atom and you're vibrating like my hands are, can we measure the distance between my hands if we're constantly vibrating like that? No, we can measure distances between them, and then we have to take all the distances and we have to average them over time. Okay? So it's the average distance. So we're going to learn to draw 3 kinds of bonds today. And it's possible, depending on what size classes you've had, if you had a really good teacher, they might have taught you about the 3 kinds of bonds you're going to learn to draw today and tomorrow. Okay? Have I given everybody enough time to draw or to write? Okay. And when you got it, Thomas?
I got it.
Okay. We're going to learn to draw the 3 kinds of bonds we're going to draw. We're going to learn to draw a single bond, a double bond, and a triple bond. We're going to start with the single bonds first, and hopefully we'll be able to get into double and triple bonds today. If we don't get there, we don't get there. But hopefully we'll be able to do the double and triple. Single will definitely get done today. Okay? Now, a single bond. A single bond is a shared pair of electrons. So, if I say a shared pair, how many electrons are we talking about that are shared? 2. Okay? So, a single bond is 2 electrons. So if I ask you this in a multiple choice question on the test, and the test won't be till next week, how many electrons should you always pick in the answer? 2. And sometimes people will say a single electron. But is a single electron ever shared? No, it's always going to be 2. So based on that, what's a double bond? That's 4. Okay? So this will be a shared, I should say 2 shared pairs, which will be 4 electrons, and this will be 3 shared pairs, which will be 6 electrons. No, you can't go beyond a triple bond. Good you can. Now, in the terms of lengths, who do you think would be the longest of those? The triple is what most people think, but it's actually the single. Okay? The single bond, with only having 2 shared electrons, is not going to pull the atoms as close. They're going to be farther apart. So this one will be the longest. All those electrons that are being shared are going to pull the atoms closer together. And so this one, the triple bond, will be the shortest of the three bonds. Now, the last vocabulary word we have before we can talk about the Lewis structures is bond energy. Everybody got what they need? All right. So bond energy. Most people think when we define this that it's the energy to form a bond, but bond energy is defined as the energy needed to break the bond. Okay, the energy needed to break the bond. The more energy needed to break a bond, the stronger it is. Okay, and I'm just going to make up these numbers rather than looking them up. So if you had a carbon single bond, and let's just say it took 200 kilojoules to break it, this one might take 400 kilojoules to break it. So what does that tell you about a double bond? Is a double bond stronger or is a double bond weaker? A double bond is going to be what? Stronger. Oh, kJ over moles. That's just a unit. That's not something you really have to know. I just can't help myself. I put units on everything. Okay? But the more energy it takes, the stronger the bond. So I'm just illustrating what I just wrote there. And you don't have to know those numbers. That's just an illustration. Okay, that's just an example. So, everybody got what they want? If I go back, y'all say no?
We got it.
Okay, so if I go back, which bond of these three would be the strongest of the bonds? Triple bond. Anything that's shorter is always stronger. So who would be the weakest of the bonds? That's right. This will be the weakest of the bonds. Okay? So what?
2, 4, 6, 8. We appreciate it.
All right. Questions on the vocabulary? All right. We're all there? It really is. Now we're going to do the not so bad part of the lesson. We're going to learn to draw Lewis structures. All right. We there? Everybody got it?
Yeah, sure.
And when you got it? Yeah? All right. So the last part of the lesson for today is all about drawing. Okay? We're going to draw Lewis structures the rest of the class period.
Lewis.
This is all like dot diagrams except much bigger.
Oh.
Now, we're going to start easy. We'll build towards hard. Most of you will be fine with drawing the easy ones. The hard ones aren't so bad either once you can draw the easy ones. Now, to draw Lewis structures, first of all, these are just pictures of bonds in molecules. So we're going to show pictures of whether they're single bonds, double bonds, or triple bonds. We're going to start easy. Now, in order to do this, here are the steps. Number 1, total all valence electrons. Number 2, choose the central atom. It is usually the atom that has a subscript of 1 or the atom farthest left on the periodic table, except hydrogen. Number 3, place all other atoms around the central atom. And number 4, last step, distribute the electrons from step 1 on each atom until distribute the electrons from step 1 on each atom until they all have 8.
You can just try being nice. It's a life skill.
She does not know how to do it.
I'm nice to everyone except her.
I know, it's a life skill.
You ain't nice to Jade at all.
I am. Me and Jason are on hot well, actually. You don't mind worrying about her. You should have seen us at work yesterday.
Yeah, we heard y'all. Talking about married and everything. We heard y'all.
Xavier, you got it?
You said I got married.
Yeah.
Date.
Yeah.
But then I had a divorce because I had to go in.
That was on. You should have just stayed with
Yeah.
you. Yeah. You'd have been happier.
I had to give up.
I should have given
I had to be married.
All right. So we're going to do CCl4. This is a nice, easy one to illustrate how Lewis structures work in a nice, easy way. Okay? So the easiest ones we could draw. So, how do we find valence electrons?
Periodic.
Okay? So, we're going to do this the exact same way that we do atomic masses and add up the formula mass. So, how many C's do we have? How many Cl's do we have? All right, so now, instead of looking up their masses, we're going to find their valence electrons. So how many valence electrons does C have?
4.
All right, we got some wobbling going on out there.
4.
I know. Now, those of you who are wobbly, if you can't do this, we're toast quick.
Okay.
All right, valence electrons. Remember how we learned to count?
Yeah, 1, 2, 2, 3, 4, 5, 6, 7, 8.
All right, carbon is here, chlorine is here. So every time you want a valence electron, you got to look at your periodic table and find what group it's in, right? So where's carbon at? Jade, where's carbon at? What group is it in?
It's in the, I have no idea.
Carbon.
Just tell me the group number or the group name.
It's in group, what is that, 14?
14. So how many electrons would it have in the outer shell that's in group 14?
4.
4. So we're going to write 4 electrons right here. All right. How many in chlorine's outer shell, Marissa? For chlorine. Whoa. Oh, wake up out there. 7. All right. So 1 times 4 is 4. 4 times 7 is 28. And what would we have done right here if we were finding a formula mass? We're still adding here, except this time instead of a mass, we have electrons. So with the N, when we get to step 4, we're going to have to draw in how many electrons? 32. All right. So to find my central atom, I said in the steps, we would use the element or the atom that only had a subscript of 1, unless there was nobody who had we had more than one that had a subscript of 1. So when I look here, which element has a subscript of 1? So that's the one we're going to make the central atom. So we're going to put C in the middle. Now, what if you had something like,
Wait, how did you figure out you see?
because it has a subscript of what right there?
1.
So whoever has a subscript of 1 is going to become the central atom. Now, what if you have something like HCN and you have 3 atoms that all have subscripts of 1? Use the one farther to the left, okay? Farther to the left of what? Well, look at your periodic table and go left. But who can never be the central atom? H. So we're not going to pick H. So we're looking at what 2 elements? C and N. And who would we pick? The C or the N? Who's further left? C. Everybody okay with how we do that? Okay, that's what I'm asking. So you got 3 elements. All of them have a subscript of 1. You see how I picked H and we said no H? Because if we go back to our steps, Jade, okay, usually the atom that has the subscript of 1 or the atom that's farthest left on the periodic table except H. So H can't be the central atom. Take it by the mix. So look at where C is and where N is on your periodic table.
Why did you pick C?
We didn't. We picked C. Okay, we're looking at C and N.
Why are you looking at N?
In this question right here. If we had that question, how would we choose the one that's going to be the central atom?
Oh, I thought you were talking about CCN.
No, I said if we had this question,
Oh, no.
which one would we pick, the C or the N?
I'm sorry, I
Save
was looking at you and I don't know my mind.
So if we had that question on the quiz later this week, you had C and N, who would you pick for the central atom? Who's farther left? The C. Are you with us now? Okay.
Oh, my bad.
Okay. So if we go back to this question, Jade, and we're back on this one. Step 3. What do I do with 4 chlorines?
Place all the other atoms around the central atom.
So how many Cl's do I have?
4.
So I'm going to draw all 4 of them around the C. Now, if I only had 3 chlorines, how many would I draw around the C? I'd only draw 3. But since I have 4, I'm drawing all 4 of them around there. Now, here's the hard part. It's not hard with a single bond. But when we get to the double and triple bonds, this is where it gets hard. So not hard yet. Don't draw right now. Just watch. Put your pencils down. If you're writing with ink, stop for a minute. Now, we have to draw in 32 electrons, okay? The nice part with single bonds is for the most part, they're going to work every time. With double and triple bonds, it's not going to work. And you're going to have to figure out how to make it work. Now, after we finish single bonds, are you going to know which ones are singles and which ones are doubles and triples?
No.
They're going to be mixed in, and you're going to have to figure it out. Don't force them to be something they're not. Draw in the dots that are required. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. Now, you have 2 rules. Do you have that number? And does every atom have what number? Have 8. Those are the 2 things you're checking. Did I draw in 32? Yes. Does every atom have 8? 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Yes. Now, this is the piece we're going to change. What are these 2 electrons doing between Cl and C? When we share, we draw a line to show sharing instead of leaving dots. Okay? Now you can draw. Okay? I'm not changing anything else. Except I'm not going to draw dots where they're sharing the next time. And I do need to give you a couple of vocabulary words that you're going to hear me refer to those as once you draw. But other than giving you a couple words, that's pretty much all the steps other than just practicing.
So you like give this to us on a quiz.
Oh, yes.
And we're gonna have to draw it just like this.
You have to draw it just like that. Yep. Only I'm going to give you a different molecule, yes. And tomorrow we're going to learn to tell their geometries and whether it's polar or non-polar.
Oh, my brain hurts.
You haven't done anything hard yet.
I just got all this stuff. When I work on this essay, my brain really going on. My brain goes like I'm done.
We haven't done anything hard yet, people.
Was tired of school.
Right.
We're just stressed.
We're all ready for summer.
It's the end of the year too. I be wanting to give up. I just want to be able to sleep.
I said, I'm thinking the end of the year.
I feel you,
It's supposed to
If
be
babe.
late.
school ended early, I would be okay. Right.
We got the longest, we got like the longest school day.
Maybe not. Right. We can sleep till about 8. I'm straight. If we can't run out of
All right.
I'll be good.
This is called a bonding or shared pair.
Oh,
And it's called a bonding or a shared pair because the electrons are shared or they're part of the bond. Now, the dots. The dots have 3 names. Okay? They can be called an unshared pair, a non-bonding pair, or a lone pair. You will hear me call it a lone pair 9 times out of 10. All right? You will call it what you learn it the first time. Whatever your math teacher or science teacher called something the first time, that is what you usually refer to something as. In math class, if you called something the reciprocal the first time, that is probably what you still call it. If they called it an inverse the first time, that is probably what you still call it, okay? My chemistry teacher called it a lone pair. That's what I still call it. But all 3 of these names are valid, okay? So you need to know all 3 of those names. I have no idea what you'll see on the exam or if you'll even see it. There are only 45 questions. You may not see anything on this for all I know. All of this stuff is fair game for the exam. Only 45 in 2 hours. Okay? Some of you will. I had two people not finish. One who left blank questions and one who just bubbled at the end last semester. Most semesters, I don't have any trouble with people finishing. All right, let's do water. All right, what's the first step? What's the first step? Count the valence electrons. So how many H's? 2. There. Okay, how many O's? 1. All right, so how many electrons are in the outer shell of H? 1. And how many are in the outer shell of O? Okay, I picked this one because this has an exception, and it's one of the 2 that I'm going to make you learn. Okay, so 2, 6, for a grand total of 8 electrons. This one has a lot less electrons for us to draw. Who is my central atom? How many H's are we going to draw around it? I mean, you're up there. Just 2, right? Now, you can choose. I am a very linear thinker. I tend to draw my H's in a line. You don't have to draw them in a line. If you saw it as an L shape and you want to draw them like that, draw them like that. Okay? Does not matter to me. I tend to be a linear thinker. I draw them in a line, but you don't have to draw them in a line. Okay? Now, 8 electrons. H is an exception. Let me change colors for that. Okay? Hydrogen only gets 2 electrons. Okay? So, as long as you remember, 1 single bond and no dots, you'll be fine. The reason for it is hydrogen has a configuration of 1s. How many electrons can go in S? 2. That's why it can only have a single bond of 2 electrons. It can only hold 2 electrons. Okay? So, what's going to happen between H and O? Are they going to share some electrons?
No.
Yes.
So I'm just going to draw a line here instead of drawing dots because they're going to share 2. What's going to happen between this H and O? They're going to share 2 also. How many electrons is this? And how many is this? 2. So there's 4. 2, 4. There's 4 of my 8. Okay? I already accounted for those. Can I put any dots on either of those H's? So where am I going to put my other dots? On the O. Because H can't have any. So there's 4. There's 6. There's 8. I can't put any on my H because it only gets 2. I drew in my 8 I'm allowed. Does O have 8? It's done. Okay? Questions? Okay. It just single bonds are easy. All right, let's do one more and then we're going to let you try. All right, so all right, let's do PBr3. All right. So PBr3. How many P's?
1.
How many BRs?
3.
All right. How many electrons in phosphorus's outer shell?
5.
Okay. How many in bromine's outer shell?
7.
So we get 5, we get 21, we get a grand total of
26.
very good. All right, so from there, who is my central atom?
P.
How many BRs am I drawing around it?
3.
And again, you can draw it any way you want to. As long as you got 3 BRs around there, I don't care where the BRs are at. Okay? You just need 3. So, from there, Where am I starting?
You share bonds.
So?
Electronic.
Doom, doom, doom. They're shared. Where am I putting my remaining ones?
Outside of the
All right, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I need 2 more. Another pair on top of the pig. So there's 26. Does everybody have 8? We're done. Everybody with me?
So I have a question.
Yeah.
Does it matter what side we start on the center?
Nope, not at all. All right, so let's do. Everybody got it?
Yeah.
All right, let me give you 3 because I don't want to do a ton here. Okay, do those 3. And then we're going to talk about multiple bonds. Mark Jonathan here while I'm thinking about it. Yes. You didn't have a note or anything, Jonathan? You didn't have a note or anything? You did? Did you put it somewhere?
Oh, yeah.
Oh, okay. Then he'll fix it if there was a reason. I'll mark you late, and if he wants to go back in and fix it, he will. Oh crap, I meant to spawn those thingy.
So question.
Mm-hmm.
For I and C,
No central atoms on side by side.
And whoever's to the left, furthest to the left is a central atom.
Yeah, you're talking about ICL?
Mm-hmm.
Because there's only 2 atoms, you just put them side by side. Wouldn't matter in that case because you have to have at least 3 to have a central atom.
So you said in that case it don't matter.
It doesn't matter, you just put them side by side.
We was on a joke yesterday after we looked at looking at shoe ball and said, that was a dog.
I'm like, geez.
Off this.
How am I supposed to put 7 eyes?
You don't.
I and CL go side by side, because there's only 2 of them, 1 I and 1 CL.
You're thinking electrons.
Oh, okay.
She said, how am I supposed to put 7? I thought it was about each other. JM.
2, 4, 6, 8. No, that was easy.
Yeah, the single ones are the easy ones to do.
2, 4, 6, 8, 10. 12, 6. Okay, I got it.
So when I add in the double bonds and then mix them, then it gets to be hard. Because then you have to figure out, are they singles, doubles, triples, or what?
Yeah, let's just say that.
Let's just say that.
Yeah.
Let's
No.
just say that.
Because if we don't, then we can't do geometry bond.
That's exactly.
Yeah, I'm sure it is. And we want to be able to do geometry and polarity tomorrow. Even though you're all going to tell me that you can't possibly learn geometries. What?
Yeah, she said I had to come here, and I said I know.
You supposed to recycle.
It's done like the recycling, so I know.
Oh my god.
I was just trying to figure out if she's really wearing bedroom shoes, but they look like slippers.
Are they moccasins or those?
They're my loafers.
Are you loafers?
Yeah. I wonder what that good if I want my husband.
They make you go home.
Are they really slippers or are they really moccasins?
No, they're moccasins,
Okay.
but I call them loafers. You look like a loafer. You're like a sloth. Shut up. Yes.
She like,
Anybody want to go first on the board? Never mind, I'll just do it. We'll be here all day.
Can I do it?
No, we'll be here all day.
All right, Glenn. I think.
I don't want to be here all day.
What on my iPad?
How many electrons did y'all get?
20.
20 is correct.
Hey, I
Now.
didn't do mine like that.
Again, do you have to have it in a straight line?
Oh, yes, I did.
no.
No. So you could have it where you had TECL bent in an L shape. It does not have to be in a straight line. Now, it doesn't even have to be bent that way. It could be bent in a different L shape. Okay? You can have it flipped up or flipped to the side. Okay? Now, SIF4 is going to look pretty much similar for everybody in the room in that there are 4 Fs. So they're all going to look, except that should be 2 dots. This was easier on the old board. Like that. Everybody okay with that one?
Yeah.
And then ICL has how many dots?
14.
14. Like that. Everybody okay with those?
Yeah.
You had to be courses that was in.
7 plus 7 be 14.
Tiffany was about to throw the name.
Okay?
How many total?
32.
You know it's
For SIF?
32.
I was like, keep going.
Anybody else have a question about any of those 3? No? Anybody?
All I heard was good.
So other than Andy's question about how many electrons, we're all okay? Okay. All right. Multiple bonds. All right. Multiple bonds would include what 2 kinds? All right. Which one are we leaving out of what you just said? That's right. All right. Multiple bonds are double and triple bonds. Now, multiple bonds have no new steps. Okay? It just alters step 4 slightly. So, the steps are the same. So, let's just draw carbon dioxide, CO2. Let's walk through the steps and I'll show you how it's different. So, what's the first step y'all just did a couple moments ago? We did what? Okay, C and O. How many C's? How many O's?
2,
How many electrons in C?
4,
How many in O?
6.
So we get 4 and for a total of? Fabulous. Who is my central atom? And how many O's?
2.
All right. So we're going to put a bond here and a bond here. And then from there, we can choose where to put our other electrons. Where do you want to put them?
Above C.
Okay, above C. Where else?
Above C.
Okay, there's 8. So now we have 8 left. You want 4 and 4 or 6 and 2?
4.
4 and 4. Okay. And if you were one of the people who wanted 6 and 2, I'll come back and do 6 and 2 in a minute. All right, so at this point, we have 2, 4, 6, 8, 10, 12, 14, 16. I've put in all 16 electrons I'm allowed. Tell me what my problem is. They don't all have 8. Okay? So, the only option I have is I have to move electrons until each has 8. Okay? I can't add. I have to arrange them, move them until everybody has 8. Okay? But I can't add. I have 16. I can't, if I could just come in and go wham, wham, that would be so much easier. But now I have how many electrons in my diagram? I have 20, and I'm only allowed how many? 16. So I can't just draw in 4 extra electrons. Well, I can, but I'm going to mark it wrong every time you do it. Okay? So I have to rearrange the ones I have. I can move them any place I want to as long as they're in the diagram. For example, I could say, I'm going to take these 2 off here and put them over here. Well, now O has 2, 4, 6, 8. But now carbon only has how many? 2, 4, 6. Well, that didn't help us. So I'm going to put these back over here. Well, now carbon has how many? 2, 4, 6, 8. But oxygen only has 2, 4, 6. So where in the diagram will it help C and O?
You move a dot from the top. And
Good Lord.
Right there. In the middle, they do what?
share.
They share. So if I take those blue dots right there off C at the bottom where they're just being held by C, and I put them right there, now they're being held by C, and they're being held by O. They're sharing between O and C. So now C has 2, 4, 6, 8, and now O has 2, 4, 6, 8. Okay, I move them into a place on the diagram where it helps both of them. I didn't add extras. So when I look at my other O over there, who has 2, 4, 6, C has how many? It has 2, 4, 6, 8. So this C who has 8 could help out this O who has 6. So what could these 2 right there do? It could take him from up here where he's not sharing and do what?
Share.
It could put him right there and share. So when I finish, I have to have 16, and everybody has to have how many? 8. So 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. I've got 8. 2, 4, 6, 8, 10, 12, 14, 16. Everybody has 16. Now, for those of you who a minute ago, when I asked the question, when we had this and I asked, do you want to put 6 and 2? And Xavier said 4 and 4. If you were like Miss Wall, 6 and 2. But I didn't go with your suggestion. This one has how many? Has 8. This one has how many? This one has how many? Can we help him out? Sure we can. What do we have to do?
Move the 2 top.
Move the top 2 where?
Right.
So now this C has how many?
6.
Sorry, the O. The O has how many?
6.
And the C has how many?
6. 8.
2, 4, 6, 8. So the C still has its 8, but the O has 6. So we helped him out. He had 4, now he's got 6. That's a good thing. But he's not quite there yet. So what are we going to do this part O? Move the other two where? Right over there. And so now he has 8 and he has 8. This has a name. These are called resonance forms. Okay, resonance forms. Okay, either answer is correct. I would not care which one you used. You get full credit for both. And there are several molecules that work that way. Questions? Nope.
We done?
No.
Yeah, she said we done.
No, Xavier said we're done. All right, let's try something else. Oh, gosh. Let's apply a skill you already have.
Never in a party.
All right, what if I give you that? What, Justice?
Crisscross?
All right. Did you hear what he said?
Yes, he said added an electron.
The only step that's new is when we add the electrons. So how many N's are there?
1,
How many O's are there?
3,
So how many electrons in N's outer shell?
4. A lot.
How many in O's outer shell?
6.
So that gives us 5. That gives us 18, for a total of 23. Now, if you were in an AP class, I would teach you odd number of electrons. Y'all are in a first year beginning class. I'm not going to make y'all learn how to do odd number of electrons. I can be kind. All right? So, that should tell you I have an error. Because y'all are not going to have odd numbers in this first year class. So, if you're not going to have an odd number, that should say, I have forgotten something in Ms. Wells' class. What did I forget? What are we going to do with this -1? This has a name. What's it called? That's right. It's a polyatomic ion. So that -1 means I'm going to do what with it? That's right. We're going to add 1, and I have 24 electrons. Now, I'll be truthful. I can't recall off the top of my head if this is a single bond, double bond, or triple bond. So we're going to have to figure it out. I think I suspect, but I can't remember. All right, so what is my central atom? Okay, nitrogen is my central atom. How many O's am I drawing around it? All right, my electrons. I know I'm going to share here, here, and here. So that gives me 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. All right, so I drew in the 24 that y'all added up. Tell me if I'm good to go.
No.
I hear I'm good. I hear some no's. I hear yes. I hear no's. Now, I will tell you, this is one of the most missed questions on the quiz and the test. Not necessarily NO3, but this structure, because of that central atom. People look at that and they go, good, and they move on. How many electrons are on that N?
6.
Exactly. And people walk off from that all the time and they go, it's got 8, Ms. Wall. It's done. It's got 6. What do you have to do? Take some dots from somewhere. It doesn't matter which of these O's you pick from. You got 3 of them. Choose. Pick the one from the top. Take 2 off of there and put them right there. Okay? Now, everybody has 8 and you've got 24. Now, last new step.
Oh. Come on. You mean I got it?
You gotta put a brown in.
Nope.
That's not nice.
Put brackets on an ion. That just tells people you added an electron or took one away.
So if it doesn't, then just leave it.
You just leave it off.
So if it's a single bond, you don't put one.
You don't put brackets on anything that's not a polyatomic ion. So if it's a polyatomic ion, the brackets say, hey, you added something there. That's all.
Do you need to put the number?
I put the -1 or positive or whatever next to it so people know what you added.
I mean, if it's a positive,
The only positive polyatomic ion y'all have is an H4 with a +1. Everything else is a minus. You subtract that +1. All right, you think you can try something?
Yeah.
All right, let's draw. What time is it? We're only going to draw 2. All right, let's draw SO3 and try N2. Try those two. Yes.
Is there the same thing in those 3 O's? Still use S or?
Yes. Because there's only one S.
Thank you.
So we only put the brackets if it has a.
A polyatomic ion. And I didn't give you all polyatomic ions, so there's no brackets. So anything on those two.
How do you know this is?
And N2? 2 N side by side.
Hey, how much homework you giving us?
Not that much. That's why you get some extra one. I did? Yeah. Hey, I'll come get it. Yep.
Yeah, actually, because he didn't grab one.
Okay. He's still groggy from his nap. right, so SO3 had how many electrons?
Thank you.
24. Who's the central atom? S. This one should have worked just like NO3. So you had, when you drew in all your electrons, somebody should have been too short, right? So whether you had too short on an O or you had S too short, most people usually wind up drawing it like this, but you don't have to. You could have had this with too short on an O, but somehow somebody should have wound up as too short, right? So you wound up, should have said, I need to fix it by double bonding somewhere to get 8 on everybody. Now, N2 only had how many electrons? 10, right? So 2, 4, 6, 8, 10. So the only way you can do that is to say share and then share again, like that. Okay? For homework. I know some of you are looking at that like this lady's lost her mind. First of all, you have a quiz tomorrow. Your quiz tomorrow will heavily come from this paper right here, the one that's the half page, plus the vocabulary we did today. Okay? Everybody listening to that?
So like multiple choice. What
It
is?
is not. No quiz this week is multiple choice. Okay? This plus tomorrow's lesson will be the quiz either Thursday or Friday. If you don't do this tomorrow, you have no practice work for tomorrow. When I say find the geometries of molecules, these are what we're using. So if you haven't drawn them, do you have any molecules to use to find the geometries?
No.
I'm not giving you time to draw to then find the geometries. You have to use your homework. So if you don't have any homework, you have nothing to practice with. Okay?
So wait, what are we doing?
When? Tomorrow?
Tonight.
Tonight you're doing both sheets.
Yeah, finish both.